Okay, good morning, class. We're busy with financial maths. You guys had some homework. It was exercise 4. Any problems? Number 1. No problems with number 1. Number 2. Okay, so I'll do the whole of number 2. Okay. So this is exercise 4 on page 72. It sounds like some of you guys did your homework today. Okay. So we are told that the school buys a new bus for 450,000 rand. The governing body decides that they will replace the bus in 10 years' time. Use a reducing balance method to calculate the annual depreciation rate if the expected book value of the bus in 10 years' time is 125,325 rand and 44 cents. So, what is the formula for depreciation on the reducing balance? A is equal to P into 1 minus I to the exponent. Okay? So, currently the bus costs 450,000 into 1 minus I is what we're calculating to the exponent 10 will be worth 125,325 and 44 cents. So what we do first is divide by 450,000. Then I take the 10th root, then minus 1, then divide by negative 1. So I is simply 10th root of 125,325 and 44 cents, which was divided by 450,000 then, minus 1, multiplied by negative, or divided by negative. Then I multiplied by 100 to get the rate. Okay? Negative, open brackets, the 10th root of 125,325 and 44 cents. That's over 450,000 minus 1. We multiply by 100. We have a rate of 12%. Okay? 2.2. Determine the rate of inflation. Again, we have to calculate R. The rate of inflation if the estimated cost of the replacement bus in 10 years' time is 971,516.25. Okay. 2.2. Inflation follows the formula A is equal to P into 1 plus I to the exponent. The expected price of the bus in 10 years' time is 71,516 rand and 25 cents. The current price of the bus is 450,000 rand. Into 1 plus I is what you're calculating to the exponent N, which is 10. So you first divide by 450,000, then minus 1. No, divide by 450,000, then take the nth root, which is 10, the 10th root, minus 1. So I is going to be the 10th root of 450,000 divided by 971,516,25 minus 1. And then multiply that by 100 to get the rate. So it's a 10th root of 450,000 over 971,516 rand and 25 cents minus 1. Yes? Yes, that's my mistake. You know, why am I getting a negative answer? Shouldn't be negative. It's 971,516 rand and 25 cents divided by 450,000. Thank you. Right? Times by 100 gives me 8%. Okay, you all agree with that? Thank you once again. So your rate of inflation is going to be 8% at average. Okay. 2.3. 2.3 says calculate the future value required in the sinking fund to pay the replacement bus. To pay for the replacement bus in 10 years' time. Assume that the current bus will be traded in for the replacement. So what happens is once you traded the bus in, that amount of 125,325.44 is used for the purchasing of the new bus. The sinking fund, which is the future value which is needed, is going to be, the new bus is 971,516.25 rand minus the replacement or the trading value or the scrap value of the bus, or the old one, okay. That is 971,516 rand and 25 cents minus 125,325 rand and 44 cents. That's going to give you 846,000. 190 rand and 81 cents. Okay. But the problem was 2.4. So we are told that the school starts payments immediately. So if it starts payment immediately, what does that mean? The variation on in. Not so. So I must add a 1 on in. Not so. What? That says start immediately. The school starts payments immediately into a sinking fund and continues paying until the end of the 10-year period. Calculate how much the school pays monthly into the fund if they receive 9% per annum interest compounded monthly. So is the monthly is the investment frequency in line with the payment frequency? Yes. You're paying monthly and it is compounded monthly. Okay? So just close here. Alright, so the formula is FV, future value, is equal to X into 1 plus I. X is what you're calculating to the n minus 1 over I. The future value is 846,190 rand and 81 cents. X is what we're calculating into 1 plus I your interest rate, which is 0.9, 0.09 over compounded monthly 12, the exponent 12 times 4. How many years will this be? 10 years. Since it's compounded and starts immediately, so it's plus 1, minus 1 over I, which is 0.09 over 12. In pursuit of calculating x, I will cross multiply first. So that would be 846,190 rand and 81 cents. Could I use the answer button as well? Must be multiplied by 0.09 over 12, since it's compounded monthly, over, so that would have been equal to x into this product factor. Okay? So what I do now is I divide by that factor, so that would be simply, open brackets, 1 plus 0.09 over 12, the exponent 12 times 10 plus 1, or I could have just put down there 21, minus 1. That's high. It's a lot of money. Is that the answer? No. That's way too high. Okay, let's just see where I went. It's 12 here. Okay, I must just align the board because I pressed the 1 and it didn't come out of the calculator. $4,381 and 6 cents. 4,318 rand and 5 cents, 6 cents. Morning. All right. So where did you go wrong, Michael?
Oh, so I forgot the plus 1 thing.
You forgot the plus 1. You must remember when that is something you might look out for me. If it says immediately, then you must have that plus 1. Okay. Any other comment with regards to this question? No? So today we're going to look at future value annuities that end early. Okay? Future value annuities that ends early. The example on page 73. Okay, so basically what happens in reality, right? So somebody's saving money on a monthly basis. Okay? So he saves for 10 years. Alright? Then after 10 years he decides not to take the money. Okay, you say, okay, I'm not going to take the money, but I'm also not going to continue my investment or by my monthly installment. So what happens to that money is that lump sum then lies at the financial institution for an extended period of time. Say it's lying there for another 2 years, for instance. Okay? Then for 2 years that money is lying at the financial institution, what's going to happen? You gain an interest, not so. And that is what we will be calculating today. Okay? That's an argument. So we are told here future value annuities that ends at, we're reading on the example on page 73. If regular payments of an annuity are stopped before the money is required, so the money is lying in the account, the value obtained from the annuity formula is the total at the time of the last payment. So once that last payment at the end of 10 years is made, that is what the formula accommodates for. Do you guys understand? It's only for that. Once that installment or that monthly the monthly investment stops, then that formula is not applicable anymore. Not so. So that's what they're saying here. So it's obtained from the annuity formula is the total at the time of the last payment. This total will grow according to the compound growth formula until the time that the money is taken out of the account. And that is what we just said now. Okay. Let's look at the example, and this is the example on page 33. Example 1 on page 33. Little Selwyn pays a monthly payment of 1,500 rand. So what does that 1,500 represent? X. Into annuity, so it's investment, earning an interest rate of 9% compounded monthly. So is the investment regularity in line with the compounding? Yes. It's a monthly investment and it's a monthly compounding. So yes, that is in order. For 30 years, so N is 30. At the end of 30 years, he stops his monthly payment but leaves the money in the account for a further 2 years. So what's going to happen after 30 months? 30 years? It's going to draw an interest for another 2 years. Okay. Calculate how much money he has in the account at the end of 32 years. So we'll start off by doing the future value calculation first. Okay? So the future value calculation is going to give you x into 1 plus I to the exponent n minus 1 over. Right, so we'll use the future value. This is for 30 years. So what will it be? X 1,500 rand into 1 plus I 0,09 over 12, the exponent 12 times 30 rand, 30 years, minus 1. Okay, here it says annuity earning interest rate. So here it wasn't specified that it's going to start paying immediately. And it didn't specify that they will start in 1 month's time. So we assume that it is at the end of the month. Unless specified that it's paid immediately, then I put that plus 1 on the time, on the exponent. You guys understand? Okay? And this is all over your interest, which is 0,09 over. So this is going to be your future value for the 30-year period. Not so. But what did we say? What's going to happen after that? So you draw an interest for how many years? 2 years. Using which formula? Compound formula. Does it make sense, people? So what I can do is I can work out this future value here. I can get an answer there. And then use that answer. Okay, we'll do that first. For the last 2 years. So let's work this out. I'll show you could have done one calculation as well. So that would have been 1,500 into 1 plus 0,09 over 12 to the exponent 12 times 30 minus 1 over 0,09 over 12. It's going to give you 2,746,000. 2,746,000. 115 rand and 23 cents. So what's going to happen for the other 2 years? The rent interest using the compound formula. A is equal to P into 1 plus I to the exponent n. What's your P value at this stage? So that is the amount lying at the end of 30 years. No? So it's 2,746,000, 115 rand and 23 cents into 1 plus 0,09 over 12 to the exponent 12 times. Will be answer into 1 plus 0,09 over 12. Again, I'll pick up the one. 12 to the exponent 24. So 2 times 12. We'll have 3 million. $285,489 and 41 cents. Okay. Instead of doing that, I could have. You guys got it? Still writing? So instead of doing this, what I could have done was okay, so that would be the future value for 30 years, not so. So what I could have said was for the total, for the final amount, we know that this will then draw an interest of 1 plus 0,09 over 12 to the exponent 12 times 2. Can you see? You just do one calculation. So that could also have been done. So it's in brackets 1 plus 0,09 over 12 to the exponent 12 times 2. So it's give you 3 million. $285,489. Come on. Okay. You guys understand? It's another way of doing it. Any confusion? No? Sorry? No. Let's look at another example. This is example 2. It's on page 74, no? Number 2. Dudley opens a savings account and immediately deposits 1,000 rand into the account. So what happens here? Immediately. So what do we do? Plus 1 on the end. Not so. Immediately and deposit 1,000 rand into the account. 1 month later thereafter and on a monthly basis, that means to say every month thereafter. She invests 1,000 rand per month for a period of 3 years. 1 month after a final payment of 1,000 rand. One month after a final payment of 1,000 rand, then increases her monthly payment to 2,500 rand. And continues these monthly payments for a further 3 years. The interest rate during the 6-year period is 10%, so it's a flat rate, compounded monthly. So is the monthly payment in line with the monthly compounding. Yes, both is monthly. Calculate the future value of this investment at the end of the 6-year period. So what do you think was going to happen here? Hey, you guys don't talk. Okay, basically what's going to happen here is that Dundee is going to pay 1,000 Rand for 3 years. Okay. So then remember that formula can only, the future value formula can only be applied once the conditions are met. Not some, that the same installment has to be invested, or the same installment must be made every month. Not so. But what happens here is that the installment changes from 1,000 Rand to 2,500 Rand. Can you see that? So because that is the case, what we're going to do is we're going to work out the installments of 1,000 Rand for 3 years. Then that lump sum will then draw in interest. Not so? So that I can use the other future value formula for the 2,500 Rand per month for the remainder 3 years. Does it make sense? Okay. So what I'm going to do is, this is for the 1,000 Rand for 3 years. For the 1,000 Rand, what's going to happen is it's going to follow that formula. F is equal to x into 1 plus I to the exponent minus 1 all over I. So what's my x value here? I'm considering the 1,000 Rand. Well, I'll put the 1,000 Rand in red. Okay, and you'll see what happens actually. Okay, so I'm going to go straight into the total. It's going to be a long formula. So for the 1,000 Rand for the 6-year period, so it's going to be 1,000 Rand into 1 plus I, which is 10%, which is 0.1 over 12 to the exponent 12 times. How many years is that for? 3 years. Plus 1, y plus 1 starts immediately, minus 1 over I, which is 0.1 over 2. So that is going to be 1,000 Rand for 3 years on a monthly basis. Not so. Then at the end of 3 years, it will draw an interest for another 3 years. So it's plus times 1 plus I, which is 0.1. The A is equal to P into 1 plus I to the exponent. Okay? Over 12 to the exponent 12 times. Are you all with me? Who's not with me? Who doesn't understand what I did so far? You all understand? Okay, so this is 1,000 Rand for 3 years. Starting immediately. Not so? Then it will draw an interest for another 3 years. Okay, that is that amount. Plus. Okay, plus. Now I'm going to consider the 2,500 Rand for the remainder 3 years. The remaining 3 years. I'm going to put that part of the calculation in blue. So it will be added to, again, future value. So that would be 2,500 Rand into 1 plus I, which is 0.1 over 12 to the exponent 12 times, which for 3 years minus 1. Why am I not adding 1? Because we are told here 1 month after a final payment of 1,000 Rand. Can you see that? That's why I'm not putting 1 plus 1 on the I, and this is all over I, 0.1 over 12. Okay. Let's see what we end up with. So it's 1,000 Rand into 1 plus 0.1 over 12 to the exponent 12 times 3 plus 1 minus 1 over 0.1 over 12. That must be multiplied by 1 plus 0.1 over 12 to the exponent 12 times 3. That must be added to What's the name in red and blue, sorry? 2500 into 1 plus, oops, fraction. The thing is not space in this calculator. Over 12. Okay, it's not, you see, it's not doing the calculation. So what I do is I'm going to do the calculation in the read first. I'm going to press equal to and use the answer button. Is that okay? Oops, times 3. That will be added to 2500 into 1 plus 0.1 over 12 to the exponent 12 times 3 minus 1 over 0.1 over 12. Is that the answer? 162,000. 162,601, comma 64. Okay. Okay, you guys understand? People, what if the question was, okay, it's not asked here. If they had asked you, how much interest did this person earn over this period of 6 years? Again, that is not the question. I'm just extending this, okay? What is the interest earned over the period of 6 years? How would you have done that calculation? We have said the total that we're getting out minus the total monthly installments that we made. Not so. How do you do that? So it's going to be, of course, you're going to get more out than what we put in. So it's 162,601 rand and 64 cents. It's be minus by how many thousand rand installments did they make? 37. And how many 2,500 rand installments was made? 36. What should I give you? Answer minus 1,000. Okay, let's just put 37,000 plus 2,500, 36,000. You'd have earned an interest of 35,601 rand. 35,601 rand and 64 cents. Will be the interest earned over that period of 6 years. Okay, you guys understand? Alright. Homework is exercise 5. You guys can start to the work now. If you have any problems, you can just let me know, okay? I'll also stop the video now.